All right, these are 11D notes. Today we're going to be graphing the sine, cosine, and trig functions. So we're going to learn the parent graphs for each one of these functions. All right, it's probably useful to have your unit circle that you made out with you. So as we go through, we're going to refer back to our unit circle. So we're going to graph the parent graph y equals the sine of x, where x is an angle measurement. All right, so here typically when we graph our sine graphs, we're going to be looking at the quadrant angles. So we're going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi, and our negatives. Okay, this is going to help us get our pattern that we're going to be establishing here for our parent points. All right, let's start at 0. So we're going to start at 0. So we want to know, what is the sine of 0? Well, let's go to our unit circle. The sine of 0, the sine is our y value. So the sine of 0 is 0. All right. Pi over 2. What's the sine of pi over 2? The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is back around, so we're at 0 again. All right, so let's graph those points. So at 0, we're at 0. At pi over 2, we're up at 1. At pi, we're back down at 0. At 3 pi over 2, we're down at negative 1. And at 2 pi, we're at 0. All right, so this is going to be half of our graph. So here's our pattern. This is one full period. We'll talk about what a period is in a moment. Of course, our graph keeps going if we extended our x-axis further. All right, let's go in the negative direction. So let's go to the negative side. So that means we're switching the direction. So we're going counterclockwise. I'm sorry, clockwise for our negative. All right, so negative pi over 2 is going to be down here. So the sine of negative pi over 2 is negative 1. The sine of negative pi is going to be 0. The sine of negative 3 pi over 2 is going to be 1. And the sine of negative 2 pi is going to be 0. All right, so let's finish our graph. So at negative pi over 2, we're down at negative 1. At negative pi, we're at 0. At negative 3 pi over 2, we're at 1. And at negative 2 pi, we're back at 0. So so we've done 1 positive, 1 negative period. Now, a period is when the pattern repeats. So if you look down here at the characteristics of our sine graph, it says for number 4, it says the period repeats 2 pi over b. b is the coefficient in front of the x. In our case, it's 1. So our period for this is 2 pi over the absolute value of 1, which is 2 pi. So what that means in our graph is our pattern is going to repeat itself every 2 pi. So there's one cycle of our pattern, and here's another cycle of our pattern from negative 2 pi to 0. So that, and here's a way to memorize what the parent graph looks like. Okay, so look at what happened here. So we're at 0, high, 0, low, 0. Oh ho low. It's my little Hawaiian girl here, like oh ho low, so like a dance. All right, here's the pattern that you can remember. 0 high, 0 low, 0. Now our domain for a sine graph is all reals. But our range is going to be between the values 1 and negative 1. All right, you can see that our x-intercepts, here's our x-intercepts, where it touches our x-axis, where our graph is 0. So those are our x-intercept for our sine graph. All right, so for sine, you need to remember oh ho low, 0 high, 0 low, 0. And it's going to help us with our pattern. All right, now amplitude, let's talk about amplitude. Amplitude is your A. In this case, A is 1. So this thing has a height, the maximum height of 1. That's our amplitude. And since it's a height, that's why it's always positive. Okay, that's a sine graph. Let's look at the cosine graph now. So we're going to do basically the same thing with our cosine graph. All right, so let's label our axis. So we're going to do our quadrant angles again. Okay. All right, so here again, we're going to start at 0. All right, so the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. All right, so let's graph that pattern. So at 0, now we're up at 1. Pi over 2, we're at 0. At pi, we're down at negative 1. At 3 pi over 2, we're at 0. And at 2 pi, we're up at 1. So here's this pattern. And these are curves. Make sure you're drawing them curves, not straight lines. So these are curves, and like I said, it keeps on going. So that represents one period, one pattern. All right, let's do the negative side now. So going back to, so we're going to go around the opposite direction. So negative 3 of pi over 2 has a cosine of 0. Negative pi has a cosine of negative 1. Negative 3 pi over 2 has a cosine of 0. And negative 2 pi has a cosine of 1. All right, so let's graph that pattern. So at negative pi over 2, we're at 0. At negative pi, we're down at negative 1. At negative 3 pi over 2, we're at 0. And at negative 2 pi, we're up at 1. So that's going to be another period. And here again, make sure they're curves. All right, so let's get that pattern. What's the pattern for the cosine graph? All right, starting at 0. At 0, we're at 1, so that's high. At pi over 2, we're at 0. At pi, we're down to negative 1, so that's a low. At 3 pi over 2, we're at 0. And at 2 pi, we're up at 1, which is a high again. So HOLO. All right, high, 0, low, 0, high. That's the pattern to memorize for cosine. All right, let's talk about domain. Domain is all reals again. All right, how about range? Well, you see that we're still bounded between our 1s, so between negative 1 and 1. All right, notice our pattern repeats, all right, over that distance. That's one period. So here again, the period can be found by 2 pi over the absolute value of b, b being 1 in our parent graph, so that's why the period is 2 pi. So how often that pattern, those 5, we call them 5 key points, repeat, that's a period. Okay, so that's our sine and cosine graphs. So HOLO for sine, HOLO for cosine. All right, let's look at tangent. So our tangent graph is slightly different. A tangent graph is going to have asymptotes because there's places where your tangent graph is undefined. That's why you have asymptotes. All right, notice where our asymptotes are defined at the odd multiples of pi over 2 times the absolute value of b. The period also changes here. It's going to change how often it repeats this pattern. It's going to repeat more often than the sine and cosine graphs do. All right, so let's look at these. So here again, we're going to start with our quadrant angles. So we're going to start with 0, pi over 2, pi, 3 pi over 2, and 2 pi, and our negatives. And every time you do need to have the scale, because without your scale, your graph's not going to mean anything. All right, so let's go look inside. Like I said, we're gonna start at 0 again. All right, and we're looking at this quadrant angles first, and then I'll go back and explain why I have additional angles in there. So let's go back and see. Okay, so on our unit circle again, the tangent of 0, 0 over 1 is 0. The tangent of pi over 2 is 1 over 0, which is undefined. The tangent of pi is 0 over negative 1, which is 0. The tangent of 3 pi over 2 is negative 1 over 0, which is undefined. And back around to 2 pi, the tangent of 2 pi, 0 over 1, is going to be 0. Alright, so let's put in what we've got. So at 0, we're at 0. At pi over 2, we're undefined. So that's an asymptote. So we're going to dot an asymptote because we're undefined there. At pi, we're at 0. At 3 pi over 2, we're undefined. And at pi or 2 pi, we're back at 0. All right, let's finish. Let's do the negative part of our graph, and then we'll go back and fill in the middles. Why do we have those middles? All right, so going back around our graph, the negative direction. So the tangent of negative pi over 2, negative 1 over 0 is undefined. The tangent of negative pi, 0 over negative 1, is 0. The tangent of negative 3 pi over 2, 1 over 0, which is undefined. And the tangent of negative 2 pi, which is 0 over 1, which is 0. All right, so see the same thing here. So we're undefined at negative pi over 2. At negative pi, we're at 0. We're undefined at negative 3 pi over 2. And at negative 2 pi, we're at 0. So we have no pattern here. So that's why we need some of those in-between points, those 45s. Now, why did I pick 45? Because the tangent of a 45-degree angle is 1, or negative 1 if it's in a different quadrant. So that makes it easier to graph. Okay, so we're going to put in our 45s. So halfway between our 90s is what we're plotting here. Okay, so like I said, back to your unit circle. So we're here. We're going to be graphing at pi over 4. Well, the tangent of pi over 4 is square root of 2 over 2 of the square root of 2 over 2, which is positive 1. So here we're at positive 1. At 3 pi over 4, we're at negative 1. At 5 pi over 4, we're at positive 1. And at 7 pi over 4, we're back at negative 1. So that's going to help us complete our pattern. All right, so let's fill in those values. So at pi over 4, we're up at 1. At 3 pi over 4, we're down at negative 1. At 5 pi over 4, we're up at positive 1. And at 7 pi over 4, we're down at negative 1. All right, so we're looking here. So like I said, if we got an asymptote, so we're approaching that asymptote. We're never going to touch it. The second piece of our graph is going to look like this. And here's this final piece of that graph on the right side. All right, let's go to the left side now. So we're going the opposite way around our graph. So negative pi over 4 is going to be negative 1. Negative 3 pi over 4, we're at positive 1. We're over here, positive 1. Negative 5 pi over 4, we're up here at negative 1. And at negative 7 pi over 4, we're back at positive 1. All right, so let's graph that. So negative pi over 4, we're down at negative 1. Finish that graph. At negative 3 pi over 4, we're up at positive 1. And at negative 5 pi over 4, we're down at negative 1. So there's that piece of the graph. And then finally, at negative 7 pi over 4, we're up at positive 1. And of course, this graph, we continue. These, like I said, these are arrows on the end of these things. They continue if our graph continued more. All right, so our asymptotes, all right, notice where our asymptotes are at pi over 2 times the absolute value of b. Here again, b is 1. So that's why we have pi over 2. All right, so it's every odd multiple. So plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, plus or minus 7 pi over 2, and so forth and so on, as far as our graph will go. Those will be the asymptotes of our tangent graph. All right, the period. When does it repeat itself? Okay, all right, pi over the absolute value of b, which is pi absolute value of 1, is pi. So see here again, our pattern is repeating now at pi. So every pi, the same pattern is going to repeat. Now with tangent, we don't have some nifty little way, holo and hollow, to remember this, okay? But just remember the tangent graphs, you do have the asymptotes. All right, so let's look at an application of this. So we're going to go. So now our A is 2. So it's going to stretch our graphs. This is a vertical stretch on our graph. We're going to multiply all the y values by 2. All right, so here's our pattern again. All right, so let's graph those quadrant graphs. Typically, we always start with our quadrant angles. All right, because the tangent graph, we need our asymptotes. We need our 45s. All right, remember our asymptotes is pi over the absolute value of b. b here is still 1, so the absolute value of 1. I'm sorry. Our asymptote is pi over 2 times the absolute value of b. So our asymptote is over pi over 2, and all the negative, or all the odd multiples of that. However many fit on our graph. So that means we have an asymptote at pi over 2, at 3 pi over 2, and if our graph continued at 5 pi over 2, and negative pi over 2, and negative 3 pi over 2. All right, so remember at the 45s we're up and down at 1. But since our amplitude is 2, this is our amplitude. Amplitude is the absolute value of A, which is our 2. That means our height is going to increase to 2 instead of 1. So instead of going at 45 going up 1, we're going to go up 2. At 0, we're at 0. All right, at pi we're at 0, and at 2 pi we're at 0. So at 3 pi over 4, we're down at negative 2, up at positive 2, and down at negative 2. Graph towards your asymptotes. All right, continue on the negative side. So here at negative pi over 4, we're down at negative 2. At negative pi, we're at 0. We're up at positive 2. At negative 3 pi over 4. Negative 5 pi over 4, we're down at negative 2. And we're getting toward those asymptotes. All right, at negative 2 pi, we're at 0. At negative 2 pi, we're at 0. And we're up at positive 2. And in negative 7 pi over 4. All right, so that's a change in our amplitude. We're just stretching it up 2. All right, so what we're now going to do now is look at how our A, B, H, and K change our sine and cosine graphs. So just like it did when we did quadratics or any of the other parent graphs we've done, H moves your graph left and right, and K moves your graph up and down. All right, so step 1, we're going to identify the amplitude A, the period, 2 pi over the absolute value of B, the horizontal shift, H, and the vertical shift, K, of the graph. We're going to draw a horizontal line at y equals k called the baseline of the graph. We're going to find the 5 key points. That's our oholo or hollow, high 0, low 0, high, by translating the key points of our 2 basic graphs, or sine and cosine, by h units right or left, and k units up or down. All right, and then we're going to do those 5 key points. Now the only thing that we've added new to these graphs that we haven't before, we've done A, H, and K before, is that B. So let's see how B is going to affect the sine and cosine graphs. Here's an example of a sine graph. It's going to do the same thing to cosine graph. So in the parent sine graph, our period is 2 pi because the pattern repeats every 2 pi. We're looking at the one in red. But if we change our B, our period's going to change. So 2 pi over the absolute value of B, which is 2, gives us pi. So what that means is now our pattern is going to repeat itself every pi. So by changing B, we can either stretch out our period or shrink in or scrunch in our period. So that's how it's going to change our graph. Now what we're going to do to make it easier with us graphing is we're going to change our units. We're still always going to graph those 5 key points, but we're going to change our units to match the period. Alright, so look at the following example. We got y is equal to 3 sine 2x minus 1. So amplitude A, the absolute value of 3, so that means our amplitude is 3. It has a max height of 3 units. Alright, there's no h. There's nothing in parentheses around with that x, plus or minus, so that our h is 0. So we're not going to phase shift. Phase shift shifts it left and right. Alright, our period, now our b is 2. So it's going to be 2 pi over the absolute value of 2, which gives us pi. So that means we're going to repeat ourselves every pi units. So that means we're going to start our graph at 0 and end it at pi. And we're going to get those 4 key points, those 5 key points in between 0 and pi. So here's where our units come in. So we want to divide pi into 4 equal units. So we're going to take pi and divide it by 4. So that's 1/4 pi. And then we want 2/4 pi. Well, 2 pi over 4 is pi over 2. Then we're going to have 3 pi over 4. And then 4 pi over 4 is back to our pi, starting this thing at 0. This is going to give us our 5 key points. 1, 2, 3, 4, 5. This is our scale for our graph. And you must scale this thing, otherwise it won't be correct if you graph it without having a proper scale on it. So those are our 5 key points, and then you need the negative ones. And yes, you have to write both sides. Alright, okay, vertical shift. Since our k is -1, that means our new baseline is going to be y equals -1. So this whole entire graph is going to shift up to -1. So that becomes our new counting, where we start counting, just like our other parent graphs. Alright, this is our sine graph. Alright, so that means our pattern is 0, high, 0, low, 0. But because our amplitude is 3, we're going to be multiplying on our highs and lows by 3. So instead of going up 1, we're going to go up 3. Alright, and like I said, we're counting from that new baseline. So at 0, we're at 0. At pi over 4, we should be going up 1, but we're going to go up 3. 1, 2, 3. At pi over 2, we're back down at 0. At 3 pi over 2, we're going to go down 3, 1, 2, 3 from that baseline. And at pi, we're at 0. And that pattern is going to continue on the opposite side. We're going to do the reverse of it. So we're going to go down 3, back to 0, up to 3, back to 0. So now you've graphed 2 periods, 2 full periods of your graph. And that's typically what our goal is. Alright, and like I said, it continues. So we're just where we were stopping our particular graph. So those are what I say, the 5 key points. That's what we're looking at. I'm going to graph them on either side. Alright, look at another example. We got y is equal to -3 sine of quantity x minus pi over 4. Alright, so the amplitude. The amplitude is the absolute value of -3, so the amplitude is +3 because it has a height of 3. And height is always a positive distance. All right, this one has a phase shift. All right, our h is pi over 4. So that means this thing is, our graph is going to move right pi over 4. Right 45 degrees. All right, our period, all right, our b is 1. So this is 2 pi over 1, which is just 2 pi. So our units, all right, so we're going to start at 0, go to 2 pi. We're going to divide that evenly into 4ths. All right, so 2 pi over 4 is pi over 2. So we're at pi over 2, 2 pi, pi over 2, we're at pi, 3 pi over 2, and at 2 pi. All right, and then we got the negatives. Okay. All right, vertical shift. We don't have any k, so it's 0. So that means we're counting from the x-axis here. Okay, so I'm going to graph my original points first, and then I'm going to do that shift. So I'm going to do this in a lighter color. All right, so you're getting sine. So it's 0, high, 0, low, 0. All right, I'm going to dot that in because this is not my final graph because I still need to do that phase shift. So at 0, our amplitude now is, all right, because this is negative, this thing has been flipped. This negative means we flip our graph. So instead of high, where we're high, we're going to go low, and where we're low, we're going to go high. And we're multiplying by negative 3. Okay? So at pi over 2, we're supposed to be high, but now because it's a negative 3, we're going to go low 3. So 1, 2, 3. At pi, we're back at 0. At 3 pi over 2, we're going to go up to 3. 1, 2, 1, 2, 3. And at 2 pi, we're at 0. All right, continue that pattern. So we want to go high, at negative pi over 2, we want to go high 3, back to 0, low 3, and then back to 0. All right, now like I said, this is not my final graph, so I'm just dotting this in because I still had to do that phase shift. I got to move my entire graph right pi over 4. Okay, so all of these points need to move right pi over 4. All right, now here's where it can get a little confusing. As far as good to have different colors too. So we want to move each of these points. I'm going to start over here with this point. So it's going to move right pi over 4. Well, pi over 4 is halfway, 45 degrees. So that point's going to move to my pink point. This point down here, 45 degrees to the right. Pi, 45 degrees to the right. Each of these are moving 45 degrees to the right. Another option you have here is get that first shift and then let that pattern take over again. Okay, so here's my graph. Now remember, this continues on. Like I said, we're just drawing a piece of it. You got to make sure you continue to have that pattern, especially if you're doing it all in one color. It's easy to miss shifting a point, and this will turn back around and go down. All right, so there's my final graph. All right, let's do a couple cosine graphs. So negative 2 cosine of x, quantity x plus pi. All right, my amplitude, all right, I see a negative, so I know, remind myself that I'm going to flip this thing. But my amplitude is the absolute value of negative 2, so my amplitude is 2. It has a height of 2. This has a phase shift. All right, remember this is minus and negative pi, so this thing is going to go negative pi, which means we're going to go left pi. All right, my period. There's b of 1 there, so this is still going to be 2 pi. So my units here are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Good. All right, so now let's see. All right, our k is 0. So we're not going to change our baseline. All right, so let's put our units in there. Okay, so now what's happening here? All right, our pattern. This is cosine. So we're at high, 0, low, 0, high. But because it's been flipped, and I'm multiplying by 2, we're going to go low times negative times 2, or negative 2, 0, high times negative 2, 0, and then low times negative 2, because it's been flipped. All right, here again, I'm going to sketch in my original graph, and then I'll come back and I'll shift it. All right, so let's do a light color so we can see what. All right, so at 0, we're going to, instead of going high 2, we're going to go low 2. All right, we're at pi over 2, we're back at 0. At pi, we're going to go high 2. And at 3 pi over 2, we're going to go back to 0. And at 2 pi, we're going to go down 2. All right, continue that pattern. So 0, high 2, 0, low 2. All right, let's dot that in. And if you got all your points, it's going to be really easy to connect your dots. Okay, now we need to shift everything. Every point gets shifted left pi. All right. So notice that pi is, we're shifting each of them 2 units because of the units on our graph. Pi is the distance between here and here. So that's one shift. Okay? So we're shifting all of these points 2 units to the left. So we're going to go 1, 2, 1, 2, 1, 2, 1, 2. Everybody gets shifted 2 units to the left until we run out of space. All right, so our pattern should continue. So we go. This point I didn't shift here. Like I said, when you might want to X the ones you shift so you can tell it moved everybody. But our pattern should still continue the same pattern. All right, so we need a point here, and then we're going to go finish our graph. Graph 2 full periods. Remember these arrows continue, okay? I find the phase shifts the hardest. You may be able to find your starting spot and then let your pattern take over from there. That's another option for this instead of having to graph 2 graphs. It's all about practicing what you're comfortable with. All right, let's look at one more. All right, so y equals cosine of 4x plus 4. All right, our amplitude here is 1, so our height is 1. Our phase shift, well, we don't have anything with our x, plus or minus, so our phase shift is 0. Our period is going to be 2 pi. This time our b is the absolute value of 4, which is pi over 2. So that means our graph, our key points, our units, are going to start at 0 and end at pi over 2. So we're going to have to evenly divide those points up. So it's 0 and pi over 2. All right, so we want 1/4 of pi over 2. 1/4 of pi over 2 is pi over 8. 2/4 of pi over 2 is pi over 4. And 3/4 of pi over 2 is 3 pi over 8. So that's our scale. All right, so let's include that on our graph. And yes, you have to write it every single time, because if you don't have the scale, the graph's not worth anything. All right, so we're going to graph 2 full periods. All right, what's our vertical shift of 4? Okay, all right, you have a better graph on your notes than I do on mine. So I'm going to change my scale so it'll match yours. I'm going to put in some extra points here. So this is going to represent 1. So I'll have enough room to move this thing. And same thing on the bottom. All right, should match your graph now. All right, so what do we got? We're not flipping or anything. This is a cosine graph, so we're high, 0, low, 0, high from our pattern. All right, because it's our shift, our new baseline is y equals 4. So 1, 2, 3, 4. So here becomes my new counting when I count my points. All right, I'm not shifting to left or right, so this is going to be my final graph. So at 0, I'm at 0. At pi over 8, I'm high, which is 1. 1's here. All right, pi over 4, I'm at back to 0. At 3 pi over 4, I'm down 1 at my low. Whoops, I didn't. Let's redo that. All right, starting my pattern again. All right, at 0, I'm high, so I'm up 1. At pi over 8, I'm at 0. At pi over 4, I'm low, so I'm down at 1. At 3 pi over 8, I'm at 0. And at 2 pi, I'm high at 1. All right, let's continue the pattern. So I'm at 0, low, 0, high. All right, so here is this particular graph. Okay, so it has amplitude of 1. All right, please, if you have any questions, especially about the units or anything I've talked about, please ask questions and we'll go over it in class. All right, earlier in our notes, we skipped this example. Let's go back and graph this one. We're going to graph y equals 3 sine 2x minus 1. Here, our amplitude is 3. Our phase shift would be like whatever's with, our k is whatever's with our x, which in this case we don't have anything in parentheses, so our phase shift is 0. That's going to move it left or right. Our b is 2, so 2 pi over 2 will give us a period, which is pi. So that means our pattern is going to repeat between 0 and pi now. So to get our units, we wanted to subdivide this into 4 equal sections. So half of pi is pi over 2. Half of pi over 2 is pi over 4. And then half of this distance will be 3 pi over 4. And then put the negatives. And yes, you must label these points. 5 points on either side. Negative pi over 2. Negative 3 pi over 4. And negative pi. Okay. All right, k. K is negative 1. So that means we have a new baseline at y equals negative 1. So let's dot that line in there, our new baseline at negative 1. All right, now it's a sine pattern. So we're at 0, high, 0, low, 0. And because we have an amplitude of 3, we're going to multiply our 3 times our high and 3 times our low. So instead of going up 1, we're going to go up and down 3. All right, now be careful. We're counting from this new baseline here at negative 1. Okay, so 0. At pi over 4, we're up 3. 1, 2, 3. At pi over 2, we're back at 0 on our baseline. At 3 pi over 4, we're down 3. 1, 2, 3. And at pi, we're back at 1, or 0. All right, let's continue the pattern. So we're going to go 3 low, 0, 3 high, and back to 0. And we want to connect those points. Nice curves. Without that little jog in the middle. All right, and like I said, our graph keeps on going. All right, so that's the one we missed.